So I'm Matthew McCullough, and my colleague Tim Berglund is here with me, and we are here to talk about the fringes of Git. We're going to try an interesting experiment, which O'Reilly also let us do in the videos that we recorded with Git with them, which is a dueling presenters type of idea. But I think it'll be interesting, and we're very much interested in your feedback for this. Two kinds of approaches and two views to everything that we're going to showcase. I said as before, I'm Matthew McCullough, and the brief intro to me is that I've been teaching classes on Git for a little over 3 years now. I am the co-presenter with Tim Berglund on the master class videos that O'Reilly let us record with them on the topic of Git. And I've also done some authoring on the Git chapter in the upcoming Jenkins book that O'Reilly will also publish. That's enough about me. Over to you, Tim.
All right. I'm not Matthew. I'm Tim Berglund. I live just down the street from Matthew in the Denver area in Colorado, and as Matthew said, I was co-instructor on the Git Master Class that we recorded with O'Reilly. And given that Git is a collaborative technology, the sort of two people working on it at once, it just works a lot better. That's a really effective format that we found we enjoyed. I also work as a consultant and trainer, developer, author, speaker, and I'm glad to be here with you today and want to thank you for signing on. So with that, Matthew, how about we jump into things? We're going to begin by talking about Git rebase. Now this is something we covered a little bit in the videos, and it's something, if you have experience with Git, you may or may not have used it. So let's take a look at rebasing. Go ahead,
I was just going to say, Tim, that today's topics, too, are largely for people who have dabbled a little bit with Git. And even those who haven't, what we're trying to do today is do something different than what's already presented. And that there are many good getting started with and hello world tutorials with Git. And some great ones have been recorded even by O'Reilly and Scott Chacon. But what we wanted to do is actually show how far it actually reaches, not just the hello world.
That's right. So like I said, I have a repository prepared for you so you don't have to watch me type in a bunch of commits, but I do want to walk through it and show you the history of what happened. If you see here where this commit here branches off and goes a couple commits in, that's where the master branch is. And then there's this other branch here called Caesar, which has a series of 5 commits. Somebody's been working in that branch. So when I rebase, rebasing is sometimes thought of as an alternative to a merge. I'll hear people new to Git say, well, should I merge or should I rebase? Well, that's not really the right way to understand it. The most common kind of rebasing, and we cover this mode in the videos, is where if I decide, like here, I branched back here and I did all this work, and I decide, you know, I wish I hadn't branched back there. I wish I had waited until these 2 commits. I want to take these two commits and kind of sneak them in the history of my branch to make that a straight line and get rid of this division here. So let's look at how we might do that. And let me just take you real quick through some of the changes I made, some of the diffs here. Looks like in here somebody added a method and somebody made a change to a properties file. And in here, these are just tiny little changes being made. There's a method added, and then a single line change there, and another single line change. So a bunch of really simple diffs here in this repository history. And if I want to do a conventional kind of rebase, what I'll do is I will go check out that Caesar branch, like that. And we'll just take a look at the log, and you can see some of those same comments, first line, second line, third line, fourth line, that we were just looking at before. And if I want to undo that merge effectively and move those commits back into the branch that I'm on, I'll simply say git rebase master. Let's look what it says. It says, first, rewinding head to replay your work on top of it. Then it's reapplying these commits in history order. Let's go back and see what the repository looks like, and notice it's like that branch is gone. But the work that had been done in the master branch is now applied in the line that my branch is in. And sometimes this version of GitX doesn't refresh right away, so to get that Caesar branch appearing there, I'll just click around there. So you see what happens there. So that's kind of the conventional mode of a rebase. Now I can go git checkout master, and I can git merge Caesar, and everything's all done. It's as if the branch had never taken place. We'll go back here and look at this visualization. So there we are. That branch is gone. If I had merged conventionally, I generate a merge commit, which isn't a bad thing. Git's very good at merging, but it can be just a little bit harder to understand the repository history. Here I get this nice straight line. Now, this is called the fringes of Git, and that's not really that fringy of a practice, but this is. Let me show you another thing you can do with rebasing. Suppose I decided, I've been told as a Git user I should commit often. I should make lots of small commits. And I think in this case I got a little carried away with that, because if you looked at the diffs I was showing you before, I committed every time I added a single line. And now I'm about to push this to the repository, and I feel, gee, that's kind of silly. That's an awful lot of commits. I got carried away. I'd like to compress those. I'd like to rewrite my local commit history, which is exactly what I'm going to do. That's a little counterintuitive, because you think, well, after I've committed it, it's a part of this immutable repository history and can never change. But since I haven't pushed this yet, I haven't shared this history with anybody, I can rewrite it using rebase before I push it to the public repo. So let's take a look at how we do that. We're going to say rebase again, and I'm going to use the -I switch, which means rebase interactive. And I see a couple of you in the chat window are happy with that -I. I'm glad you are. This is a good thing. So to make this work, I have to pick kind of an anchor commit. I want to go down below the commits I want to edit. And all these 5 right here are the ones I feel a little bit bad for. I feel like I made my commits too small and too many of them. So I'm going to go one below and copy and paste that tree-ish there. Now I'll run git rebase -I, and my default text editor opens up with this git recipe, or rather this rebase recipe. Here's a list showing all of those 5 commits that I identified, and down in the comments here, this really helpful legend that lets me tell Git what I want to do. If I just saved this file and exited as it stands, I'm picking each of those commits, so in other words, I do nothing. But what I want to do is squash them. So I can just put an S on all those, which is effectively going to roll all those commits up into this and make one big commit with all those changes in it. I had made 5, I only want to push 1. Do that, I'll exit, I'll come back here to the command line. Some things flash back and forth. I don't know how you saw that in the desktop sharing application, but we now get back to my editor where I'm being asked to prepare a new commit message. So this is the revised commit, all 5 of those commits squashed into one, and I can just give it one nice clean message. I'll say I wrote a method to emit Mark Antony's speech after Caesar's assassination, which is what that method is. So there we go. And I'll do another git log. And you'll see that I always mistype that. There are a few git commands I always mistype. That's one of them. You'll see we have this commit changed in the properties file that we had seen before, and above it just one greatly simplified commit, wrote a method to emit Mark Antony's speech after Caesar's assassination. You'll see I misspelled Caesar's there. Matthew, that would be a great time for me to show commit amend, but we've talked about rebase enough, and I want to hand it over to you so you can talk about the reflog.
Excellent. Thanks, Tim. I'll take over both the audio and the screen sharing from you. And if you want to stop the screen sharing, I will toggle to mine. We are equally at a command prompt. This is now Matthew talking. And I want to show you something that can kind of save you from what Tim just taught you. There's a little bit of embedded humor in that. Tim, as much as you tried, maybe somebody fat fingers what you just typed there, and things go wildly wrong. Are they hosed? Can they ever get back to those commits? We're actually going to look at a command called reflog. Git reflog is an ability to look back at the things you've done. I need to add 2 constraints around this. One, it's not the activities that have been committed to the repository. It's the actions that you've typed. Seems like a very small difference between the two, but it's very significant. This is what you've done, both in a forward and rewinding kind of application. Checking out branches, creating new commits, amending commits, performing rebases, performing merges. It is a local journal that only lives on this clone of the repository. It's actually why it's important to keep your clone of a repo around. It's really not a good idea, or you're losing value, if you actually just throw away your clone and start again some other day, especially if you find yourself in a corner case that you can't seem to get out of. It's important to keep your clone because this history has value above and beyond what you've merely committed to the repository. I typed git reflog, and that's the easy way to start off viewing this output. What is it that it's actually showing us? It's a form of log output, chronological from the newest thing that we've done at the top to the oldest thing that we've done at the bottom. The two first columns there are 7 characters of a hash, a ref, for a particular commit, and then a symbolic equivalent, head, and then an integer number. Now keep in mind, as we do more activity on the repository, that integer number will change. It's pushing the rest of the list down. So those numbers, head at 0, for example, are only valid until we perform the next operation, at which point it'll become head at 1. The refs, or hash, on the left-hand side are a permanent way to refer to the same thing. They're synonymous. So look what this is telling me that I've done to this repository. Recently, I've just been checking out various points in history. Prior to that, I actually made a correction to one of the commits with amend. A little bit earlier than that, I cherry-picked one of the bits that Tim coded into the repository here. Prior to that, I did a few rebases, interactive, the technique that Tim just taught us, and so on down the list. You see, it's a list of actions that I've performed, not just merely commits. Now, if I did something quite dramatic, going back to the prompt and clearing the screen, I'm going to do a git log and show some history here for just a second. I changed a properties file. I had some additions by Tim, some more idiomatic groovy corrections over there, and perhaps I don't really find any of those things very valuable. I'm going to copy this little bit of commit that's me 3 commits ago. I'm going to use the git command reset hard and set back to this point. What is that actually doing for us? That's actually throwing away the last 3 commits and taking my current branch, master, and setting it to this point. I'm throwing away Tim's 3 pieces of work and resetting master to be this point, the last commit that I, Matthew, made. Done. What if I was off by 1? What if that was a typo? What if I really didn't mean to do that? Well, it's awesome on one hand that Git lets you manipulate history, but seems like that's really scary and you could lose a lot of history. Let's go back to reflog for a second. Let's take a look at what new activity just happened at the top. Updating head to a particular commit. That effectively is throwing away what Tim did. Now, the point before that is not linearly just the commit before that, but what the entire repository looked like before I just issued that destructive command. I'm going to choose head at 1 and copy that to my clipboard. I'm now going to git reset hard, and that looks like the same command that I just used destructively to throw away Tim's changes. But this time, I'm going to set it back to one of these symbolic points. Enter. Change the properties file. Let's now look again at our log and see that Tim's changes are back. I just toggled between throwing away 3 of Tim's commits, realizing I shouldn't have done that, and then toggling back to putting them back again. Git actually has a concept very similar to the JVM in that objects are not immediately garbage collected. The fact that I quote-unquote deleted Tim's commits really just meant that I broke the link and the references to them. They're actually still there, ungarbage collected, sitting in the .git/objects directory, and waiting to be restored or garbage collected if we don't use them for 30 days. I just restored a very serious correction, restored the code, making a correction to a very serious mistake of throwing away code. If a merge goes badly, if a rebase goes badly, if a cherry pick does not go correct, if any other manipulation of history doesn't turn out correct, git reflog, find the point at which things were good, the last activity that you did, such as checking out master that took you to a good point, and git reset hard to that particular ref, and your code is restored to that view. But even funnier, I would say, is the fact that I can toggle back to having deleted Tim's commits. Remember, this is a history of what we've done. I could grab head at 1. That was the point after which I trimmed off Tim's commits. And I can equally git reset hard, returning to the point where Tim's commits are trimmed off. Git log shows us the history, starting in reverse chronological order, and indeed, Tim's commits are now gone. Let's restore them one more time, but what are we going to have to do? Well, head at 1 is no longer a valid point, so let's get reflog again and see where did we want to be? Well, it makes sense to grab head at 3. That was that last good point. Let's restore ourselves to that good point. I now have Tim's commits once again. So it's iterative. It's not just one pass or one layer of safety net, but in fact going back as many times as you'd like to as many places as you'd like. Now, I instantly restored that with a git reset hard, but is there a way to peer into what's actually offered by this reflog? Let me take a few Unix commands and show you exactly how we can do that. You saw it was columnar in the output of reflog. So what if I took a Unix command, so let's take reflog, and attached it to the end of a pipe over here, say cut, and I took some of the columns, characters 1 through 7. All right, I can understand where that came from. That's just slicing out that first piece of reflog. Now, where can I actually use this? There's a visualization tool that's platform independent, git k, and we can open that up. When I open that up, I simply view the history and everything that has a label and a name. Groovy eyes, that's a branch, master, a tag back over here, code baseline. So with all those pieces in place, it's just a boring history as could be shown by any other tool. But let's quit that and actually return to the command prompt. Let's combine git k's power. Let's use the all switch to view all branches, and let's feed it a series of refs. Wrapping this in a nested set of ticks over here to pass the result of this into git k. Let's do that same cut, Charlie 1 through 7 for the columns there, and then close the tick, routing all of that information over to git k as a visualization. Wow, that's got a lot more decoration than last time, just a simple straight line. In fact, you can see what are labeled orphans over here on the side. Things that don't have a name effectively have been reset away, or branches that have been discarded. There's an orphan. There's an orphan. There's 3, probably a branch we're no longer using. a branch and a branch from a branch, and some other branches and some individual commits down here. When I highlight each of these, the ref, or SHA-1 hash for that commit, is shown here in the bottom. Just like using a portion of reflog, in fact, it's just a visualization of reflog, we can grab any of these markers here in the graph and do a git reset hard to that point. But that's not the only command that we can issue with these orphan commits that reflog allows us to see. We could cherry pick them in, which is like a merge of one unit of work. We could use a traditional merge, which acts as if they actually were a branch and folds the code into our current branch that we're sitting on. We could git show to view the contents of one of these refs, git log to traverse the history, even though it doesn't formally have a name. All of this is a means of actually showing what we have in our orphaned objects, what we've interacted with previously with reflog, but now in a graphical form instead. So, returning to the command prompt for one final pass on this, what else can we do for kind of maintenance and history on this repository? Well, if you have a reflog entry and you'd like to manually maintain it, you can actually delete particular entries. Reflog lets you delete, and that's simply the pointer to it, not actually the objects being garbage collected themselves, to clean up this history. It's rare, but nonetheless, it's interesting that it offers you that ability if there's some useful reason to prune a repetitive set from this reflog history. Maybe you have something in there that's sensitive you'd like to remove. You can reflog delete a particular entry like so, and the next pass that we run through reflog, now missing that element. Everything just kind of collapses to fill the gap. Rare to delete it, but very common for Git masters, if you will, to use reflog to correct from any type of branching, merging, rebasing, or resetting mistake. Gives you 30 days of history by default, and you can scroll through that history. So with that piece in place, I'm going to return control over to Tim for his next part. Tim, I've finished the screen sharing. Back over to you.
Thanks, Matthew. I am going to kick off the screen sharing, and we'll just make sure this all goes well. So thank you for that tour of the reflog. That is, to me, mind-blowing stuff, the way you can track history and change history like that. So something a little more tame. We're going to talk about tracking code, not files. May not be obvious what I mean by that, but I will explain. So let's take a look. Again, just refamiliarize ourselves with this repo. Here we are, right where we left off. We had this commit where I added some code to this class to emit a speech. So there's this Mark Antony method. Let me just grow that a little bit so everyone can see it. There is this Mark Antony method, and this is Groovy code. It's returning a constant array of 4 strings. If you don't know Groovy list literal syntax, that's all that means. I'm returning a list of 4 strings. So how about I add a little bit more code? How about I got that method down there. I'm going to go down here and go for another poem. And just throw a couple lines in here. If I had been a heathen, oops, I need double quotes. I'd have praised the purple vine. Your presenter is not required to get quotation marks correct. My slaves should dig the vineyard. I would drink the wine. Very good. Okay. So we got that there, and I'm editing my code. I'm going to go add a little bit more here and say, woe to the hand that shed this costly blood. And we'll just leave it at that. Okay, so a couple of changes in that file. Now, if I go back to the command line and I run a git status, we pretty much know what that's going to say. It's going to tell me I've modified the file called person.groovy. And if you know anything about Git, you know the thing I'm going to do at this point is something like this. Git add everything, and then I'll do a commit to make those changes stick. But let's say I want to be a little bit more picky than that. I can use the -p flag. And let's watch what this does. This is kind of cool. I'm going to say git add -p. It's going to traverse through the diffs in my working tree. So the current copy of person.groovy that's different from what's in the staging area. It's going to say, all right, here's your first diff. It looks like you added a line. Woe to the hand that shed this costly blood. Do you want to stage this hunk? And that's what it calls each diff. It calls it a hunk. So I'll say, yes, I want to stage that hunk. That goes into the staging area. Now, here's the text from the Chesterton poem. I'll say, no, I don't want that to go yet. All right, now let's look at what git status has to tell us. Kind of a confusing situation. It says you have changes to be committed in the person.groovy class. It also says changes not staged for commit in person.groovy. Now that's not normally what that looks like. Normally you'll see a file down here. It'll tell you, look, you have to stage this file that you changed, or you'll see it up here saying, thank you for staging that, it's ready to be committed. But of course, person is both, because we only staged part of the change. So I can now do a commit, and I'll say added another line of Shakespeare, and that's still there, and I can now add that completely, and I'll say added some Chesterton, and we're back to a clean status, both of those added. So the git add -p is going to allow you to traverse through the diffs in each changed file, and you make the decision whether you want to add them. It can be convenient. Sometimes we can use our version control system to help us work through changes that we've made that maybe the rest of the world isn't ready for. Good stuff. So with that, let's talk about how Git deals with moved files. And let's just take a look at this project we're in. We've got this directory called the app, and this is a fairly conventional Java application. If you look down at the bottom here, there's a source directory, and there's a main and a test. Groovy, the package is org.gettraining, and here's this Caesar.properties file down here in that directory. Well, I'm going to decide I don't really like that there. I didn't mean it to be in the training package, so I'm going to move that simply to the top level. And I'll run the tree command again, and you'll see here it is, the Caesar properties file under the Groovy directory, no longer in the org Git training package. So I've just moved it in the file system, haven't told Git anything about it. What Git now says is a file has apparently been deleted because it's not there anymore. Oh, and by the way, there's this new file I haven't seen before that I'm not currently tracking. So let me go ahead and quickly add that file. Now, when I run status, what happens? See, Git detects that the file has been renamed. Now, you have to know just a little bit about how Git is put together under the hood to know how it gets away with this so easily, and frankly, to know some of the things we're about to look at next. Every file that gets stored in a Git repository gets stored in its entirety. Each commit doesn't store diffs, but it stores a new and compressed copy of that whole file, and it stores it sort of indexed by its SHA-1 hash code. So when I move a file from one directory to another, Git can say, oh, this is the file with the same SHA-1 hash code that just happens to be located in a different directory. So it's pretty easy for it to find moved files like that. So let me go ahead and commit that. Actually, no, let's not do that. I'll just say repackaged some stuff. There we are. And now If I look at the log, I see, as Matthew has been showing me, a fairly conventional view of the log, of the commit hash, the author, date, time, and the commit message. Now, if I want to know what happened in each commit, I can give it the -- stat switch. You notice this most recent change, it's saying I added a file, these green pluses out here, in the Groovy directory, Caesar.properties, and I removed a file from the org git training directory. So that's that move operation taking place there. And we'll see in commits later on, changes were made to person and so forth. So that's what -- stat shows you. Let me show you one more switch, and that's -m. When I run that, notice what happens in that top commit. Instead of seeing he added a file and then he deleted a file, suddenly Git is inferring the move right here. And this formatting of the path, unfortunately, takes a little bit of explanation. So let me walk through this with you. We have, starting from some directory in the past, this Groovy directory, and past that confusing stuff, you'll see Caesar.properties. And what's inside in these curly braces is Git telling you this file was moved from having been in groovy/org/git training to being in simply /groovy with no additional paths there. So you have to tune your eyes to look for those curly braces, but that's how Git shows you that the move has taken place. It's important to note that there's no such thing as a move that gets stored in a Git repository. This is Git inferring that the move has taken place by the files that have moved around, recognizing that they're the same according to their hash code. And simply inferring that and putting it in the log message for you. There's nothing you can go read out of a commit that says a move has taken place. Quickly, I'll show you something similar. Let's see here. What I want to do is edit that properties file. Actually, no, let me not do that. Let me show you Git inferring a copy. I think that'll go a little bit more smoothly. So I'm going to go to source, main, Groovy, Caesar, and let's decide, for reasons of my own, I want a copy of that in the test directory, like that. There we are. And I will add that. I'll go ahead and do a commit. Now when I do a log, I don't see that it has told me that the file has copied.
Oh, that last -c piece, Tim, for -c there, showcases really the difference between just the renames and the copies. And it's interesting to note that -c gives you both rename and copy display, whereas -m is purely just the rename.
That's right. So let me show that again to be clear. We'll show -m, which didn't show that the copies had taken place. And the final switch I'd put on there was this find copies harder that told it to go and look for copies to take place. And again, we get this somewhat confusing notation here, but once you know to look for these curly braces, Git is telling you this Caesar.properties file was moved from the main to the test directory, and it's able to pick that out. Okay. With that, that's tracking code. Matthew, I'm going to hand it back to you to talk about the log and how to search through the log for things we've done in the past.
Excellent.
Not before
Thanks, Tim.
disabling screen sharing.
We're equally going to toggle over to my console and give this concluding chunk of demonstration for this webinar. And that is an interesting form of looking back through history. Log is typically thought of as just a means of viewing reverse chronological order of what we've been doing in a repository. That's fine. Git log, as you've been showing and as I've been showing, is at a starting point exactly that. But log in Git takes things a little bit further than just reviewing this reverse chronological order of history. It has a couple of switches that are interesting that we can add to it. I'm going to approach this from two different vectors. I'm sitting in this same code base that you are, Tim, and I'm looking at a file called person.groovy here. As is present in some other version control systems, I can say git blame person.groovy and ask how this file was composed. There's some useful information that can be derived from this. I'm going to shrink this rather to a small font just so that we get enough of the code on the right-hand side for this first pass. We have a hash, the file name, the author, Tim and Matthew interspersed, the date that we made that commit, the line number of code, and then the representation of the source file from beginning to end, all 21 lines, on the right-hand side. That tells us who made the change that made the line look like that. But it doesn't answer any historical questions about who took out a constant, who added in a method, and can I see all the deletes but not the adds, or the moves but not the adds, or the copies but not the renames. All of these things can be actually separated out by the form of log. So while blame is a good go-to tool, log becomes the more powerful variation of this. We can start off by doing a git log-g, which is interesting because it actually ties back to roughly where we started with this webinar. This actually shows all the history, even things that are orphaned and no longer committed to the main branches that are well known and named. Log-g. Showing things, aha, there's that reflog syntax at the top of each of those. Interesting. That's simply the -g switch added to that. But we can go a bit further. We can actually look for -g and then also view some of the history that goes along with this and filter it to a certain set of results. For example, I want to view all the history, including things that are no longer connected to the graph, and I'd like to filter them down to just diff filter, and I want a code of, and there's single letter codes for this, we'll give the reference after the lecture, A, D, R, C, copies, adds, deletes, moves. So, for example, I just want to view where diff actually produced deletions. I'll go back through history. But I'm not actually viewing the code. So I'll add another option switch. This time, I'll add -p, which says, show me the patch file, or in fact, the change is the way that we could think of it. Show me the code that changed in each of these commits. -p at the end. Each of these are red, dark red, because we're only viewing the deletions. We can narrow it to subsets like this. Not bad, but can we get even more precise? We can. I'm going to come at this from another vector, git grep, another tool in the stable of git commands. We can search the current checkout of code for something like test person name, a constant that's in my code base. I can type that and, oh, it's not found. It's not in the current code. Interesting. I know that existed. I'm sure it's there. I wonder if somebody's taken it away. We'll toggle back over to log again. This time, we'll add -s, which says look for a string appearing as an addition or removal to anywhere in the history. Essentially, look in the patches for where this particular change has been added or removed, this string. We'll look for that and we see, oh, yes, that actually makes a lot of sense. in the commit where I constantized the code. This is what got added. Let's add -p to the end, combinations of things that we discovered a minute ago, to actually see the code change itself. -p, now showing me that same commit, constantize, that I did yesterday, and now also showing me the code with the lines removed and the lines added back. That's actually taking away embedded strings and using the constant instead. So I actually can work my way through the entire code base using something like -s. Now, with that search, that only looks and shows me the files that actually participated with that kind of a diff. What if I wanted to view all the commits and all the files that contain those changes? In other words, the sibling files that didn't exactly have that constant, but were bundled with the same commits that did introduce or remove that constant. I can add pickaxe-all to the end, which says, show me same commit, but all the files that participated in that commit, not just the one that introduced that particular constant. We can go one more round with this, which is regular expressions. So let's prune it back to kind of the starting point, get log, and introduce -g for regular expression. This time, let's look for all methods either removed or added that begin with set, and then using regular expression notation, have an alphabetic set of characters. It's got to have at least one of those, plus. And then let's make sure that it has a parentheses. We want to make sure that that's actually a method that we're looking for. And we'll call that good and show me the code. This is all the places that introduced or removed a setter. We'll see a couple of those, starting with the one towards the bottom of the screen. Set age, in that case. There's another commit that did something of the same. Let's see what hit we get down here. We've got a change that introduced a setter, set out. I see it right there. But could we even be more precise? These switches can all be combined. So what if we said just diff filter, where that pattern was a deletion? We can narrow it down to just that. Same regular expression, same code output, now only looking specifically for deletions. None. How about additions? Yes. Do you notice how all the text is green? We're only viewing adds, not removals. The combination of these, like logical ands, are just incredibly powerful. The last thing that I'll show you in terms of log is kind of a lighter weight way to finish. Get log -p shows me all the code changes. Big deal. I could review all of these. But it'd be nice occasionally to check for what I consider anti-patterns, where people are making formatting changes that really are detrimental to the rest of the team. Maybe not to compiles, but to good formatting of code. Introducing spaces in front of tabs, or trailing spaces on the end of lines, or trailing tabs. --check. We can do away with the P for now. Look for spaces introduced in front of tabs, or trailing spaces at the end of lines, and show us where those have occurred in the code base. Tim, unfortunately, you're a culprit. Right there on person.groovy19, you added some trailing whitespace to that file. Working our way back through the history, I'm equally complicit in this crime. Person.groovy, I added some leading spaces in front of some code that I reformatted. That was yesterday. I did so knowingly to create a good example here. So lots available with log. Tim showed you -m-c -find copies harder. I showed you diff filter, check, -s, -g, and pickaxe all as a means of digging in ever and ever more precisely to the output. showing just the commits that had a certain condition or a certain rule around them. With that, the end of my demo and the end of the 4 pieces that we had prepared for today's lecture. So probably time to take Q&A at this point, of which we have a pretty rich set of questions on the side. Catherine, any guidance here?
No, I'm going to leave it up to you guys to pick and choose from them. They're in chronological order, so go ahead and just take it away.
Tim will alternate for the sake
Matthew,
of good audio, so we'll just bounce and... Go ahead, Tim.
Okay. Go first. Take that first.
All right. So I'll read off the question and take one, and then we'll toggle and let Tim answer the next. So the first one that I saw was, with all the rebasing and reflogging, what happens to a change if the intervening change is removed? The point to keep in mind here is that reflog is just a journal. It actually is not the structure itself. The structure exists separately. Hence, why I said it was important to keep your copy, your clone of a repository locally. The structure itself is Git tracking the files. The reflog is literally just a diary or journal off to the side. So any changes that you make to the reflog, say with the delete command that I offered, are non-destructive to the history of the code itself. With that, that one's answered. Over to you, Tim.
Thanks, Matthew. George V. Riley asks, Tim, how come your command prompt is so awesome? I want to be like you. Well, I'm paraphrasing a little bit. He said something close to that. But that's a bash script, George, that I've got in my bash profile. And if you email me, I can send you that code. I know Matthew has that code in a repo. And he'll probably be able to give us a URL for that, Matthew, when I hand back to you. If you know that, just give it. Otherwise, George, shoot me an email. I assume my email is in the, the show info, and I will send you that code.
Tim, I actually just put that URL in the chat window, so perfect comment. bit.ly/get links towards the bottom of the page. Both the bash and the Z shell one are open sourced over there. So third question. If I have, so this is Ryan Shelley, if I have 2 changes in one file with git commit -p, is there a way to move some changes to stash, some changes so that you can temporarily work on them? In other words, can you take what you did, Tim, and go further with that commit p? And I am going to break mode and actually go back to screen sharing for just 30 more seconds to answer this. It's much better to show it than it is to simply talk about it. So over here on my command prompt, I'm going to clean the screen once again. I'm going to get status to show that I have no local changes. I'm going to add a couple of lines to person.groovy. I'm going to throw in one right here at the top, line 1, and I'm going to head to the bottom of the file and throw in a new line over there, line 2. I'm going to escape, write, and quit. That file is now saved with 2 lines of changes. I'm going to git add .-p, as Tim did earlier, and I'm going to answer the question that, yes, I would like to stage line number 1. No, I would not like to stage line number 2. In fact, I can then git stash and add the same -p flag to the end. Stash accepts the patch mode as well, and it can prompt me for line 1, no, leave it alone. Line 2, yes, stash it. Get status now tells me that I have one thing in the staging area, line 1, and get stash --list will tell me that I have a commit over here in the stash that includes that small change to the last line of the file. So yes, in fact, I can split with -p not only with just adds, but with stash as well. Tim, back over to you.
Okay, I'm going to bounce around a little bit here. We're short on time, and I want to say Oldest Bojar's question with git reflog delete. If you delete a change in the middle of the reflog, what will the repository look like now? That's kind of a repeat of Michael Ritchie's question that Matthew answered at first, which is that the reflog is just a log. It's not changing the underlying structure of the repository. I'm also going to skip the question about Git with Xcode 4 that Michael Ritchie asked. Can you discuss using Git with Xcode 4? My answer is no, I can't. I'm not an iOS developer, so I'm going to let Matthew take that in just a minute. But Michael also asked, is there a free online repository site that allows private repositories? I'd like to mess around, but my code is not open source, so GitHub won't work. What he's referring to is to have a private repository in GitHub, you have to have a paying account. Otherwise, your repository is open. And the answer, Michael, is unfuddle. You can have private repos in that. In the free account, you're fairly limited to how much you can store and so forth, but that's what you'd want to look for. And I'm going to hand it back to Matthew. Going out of order now, Matthew, if you want to talk about Xcode briefly.
Thanks. Sounds good, Tim. So, Tim, if you're preparing in the meanwhile our closing 2 slides, I'll just take these last 2 questions and we'll end precisely on time. So these 2 final questions, Git with Xcode 4, it is awesome integration, but it is not the full set. It offers the basic push, pull, branch, commit, add to the staging area, but not to the level of precision that we've done in today's webinar. I think that's true with almost all the graphical tools with Git, and that they offer the core functionality set, but they leave the nuances back to either the command line or to the most dedicated of GUIs for ones, say, like SmartGit, Tower, or the like. So primarily you'll see just the standard path through the tooling be available in Xcode. Last one is, are stashes listed in reflog? And I actually need to go back through the code of Git over the last 6 months and see what's changed. Previously, the option switch git reflog -- verbose would give you the stashes listed in reflog as well. And as of the current 1.7.3 and 1.7.4 versions, those are no longer present, and the verbose option is no longer available for the traditional reflog show. So at the moment, no, those are not shown. There may be an introduced new option switch that isn't documented. It certainly is not in the man page. Previously, -- verbose would give you those, but as it stands right at the moment, it does not. So with that, I hope you've really enjoyed all the stuff on the edges. As we said, there are plenty of welcome and getting started to Git, but we thought it'd be fun, and O'Reilly offered us the opportunity to show you really the edges. And it's some interesting things to explore. Even if everything didn't absolutely solidify with you, you'll have recognized that Git has really, really long reach in what it's able to do with source code. And all of the things that we typed today will be published at that bit.ly/Git links in a HTML form so that you can copy and paste the commands that we used in today's presentation. Tim, back to you for closing.
There, do we have audio? Can you hear me? Good deal. All right, Matthew, thank you very much. And I just want to repeat, really thankful to everyone who was here. I hope this is valuable to you. Matthew and I would love to hear from you. Let the folks at O'Reilly know if this is valuable to you, if you'd want to see more like this. Here again is the bit.ly/Git links URL. That's a great collection of resources. Matthew, on his part, is a machine in gathering Git resources. I've got a few things in there too, so that will be helpful to you. And we want to remind you one more time, bit.ly/ogitvid. Tell your friends, and we'd encourage you to check this out. If this seemed like it was the fringes and you need the core and you need to learn some basic Git, check that video out. Those videos out. I think you'll enjoy them a lot. And again, I want to get you out of here on time. We respect your time, and thank you tremendously for your attendance. Hope you have a good day. Bye, guys.
Hey, Matthew and Tim, Catherine here. I just want to say thank you. That was I mean, that was really an awesome presentation, so thank you, and I usually don't say that. I also want to thank all of our audience because we had a great turnout today. Very intelligent people, good discussion, and I enjoy that so much. So thank you, everyone, for making this a great event. Hope you'll join us again, and I'll send everyone a link to the recording as soon as we have that ready. It should be later this week. We'll get on it right away. So, yes, the presentation will be available. We'll send you a link, and as soon as it's ready. If you didn't register for this, we won't email you, of course. So watch our webcast page, and that's O'Reilly.com/webcast. That's it. Thank you, everyone. Goodbye.